Hey everyone, we're doing a quick tutorial. Wait, what do I do? Again, this is just a way to remind ourselves about how we do these different calculations when we're at home working on homework and we can't exactly remember how we did that in class. So this is our quick tutorial on variance and standard deviation. So as we talked about, how you calculate variance and standard deviation is slightly different depending on if we're talking about a population or a sample. So the first time we're going to go through with a population. And so this is the example that we previously worked on. Again, we have a set of scores. The first thing that we're going to need to do, if we don't have a mean, is calculate that mean. So here, if we added 1 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 5 plus 15, divided that by our number of scores, we get a sum of 45 divided by 9 gives us a mean of 5. And now that we have that mean, we can start getting those deviation scores. That's that step one in calculating that variance. So we'll just take each x value, each score, and we'll subtract the mean. So 1 minus 5 is negative 4, 3 minus 5 is negative 2, 3 minus 5 is negative 2, 4 minus 5 is negative 1, 5 minus 5 is 0, and 15 minus 5 is 10. If we were to add all those values together right now, we would get 0. And this is why we have to do the next step, which is square those deviation scores. Because again, our mean is our balance point of values. If we look at the deviation from the mean and we add them all together, we get 0. So to solve that problem, we're going to do step 2, which is square each deviation score. So negative 4 squared is 16, 2 squared is 4, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, and 10 squared is 100. And this is where we really want to add them all together for step 3. Add up all those squared deviations. Again, this is that definitional formula for sums of squared, and we get sums of squared for our x value is 126. That's the value that we're going to use in step 4 that goes into our variance equation. So 126 divided by the number of scores. Here we're dealing with a population, so we have 9 scores. 126 divided by 9 gives us 14. So that's how we calculate variance. Now, remember, the kind of gold standard of ways that we talk about variability in a distribution is actually standard deviation. But standard deviation is really easy to get once we have that variance. So we have that variance of 14. All we're going to do is take the square root of that value, and the square root of 14 is 3.74. So here in our chapter 4, variance is just a step along the way to getting to our standard deviation, which is typically what we'll use to describe data. But those sums of squared and those variance are going to be important tools that we're going to use later in other sections as well. So again, how we do this for a sample is going to be very, very, very similar, except we've got a couple of little changes. As we discussed, a sample has less variability than the population does. And so to do a better job of estimating it, and because of the degrees of freedom we discussed in class, our formula is going to be a little bit different. So instead of taking our sums of squared and dividing it by n, we're going to take our sums of squared and we're going to divide it by the degrees of freedom. In this case, degrees of freedom will be n minus 1. So how we calculate the sums of squares is going to be just the same. Again, if we don't have a mean already, like we don't have here, we have a sum is 32. We know we have 8 values, so 32 divided by 8, our mean here for our sample is 4. Another way that we can tell that we're dealing with sample and not population is that we're dealing with Latin, right? We have the m value for mean and not mu, so we can see that we're talking about samples and not population. So again, that first step, just like for sums of squared, just like we did for population, this part is absolutely identical. We'll calculate those deviation scores. So 1 minus 4 is negative 3, 2 minus 4 is negative 2, 3 minus 4 is negative 1, 4 minus 4 is 0, 6 minus 4 is 2. Again, if we were to add all those together now, that's a good way to check our work so far. And again, those will all add together and equal 0. But what we want to do is we want to square each of those deviation scores so that they don't cancel each other out. And we can see kind of, okay, well, how much spread is there in this data? And so we'll square each of those values. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 2 squared is 4. And we'll add all of those values together, add up those squared deviations. That gives us a sums of squared for these x values of 26. Again, we've had a tweak, right? So instead of sums of squared divided by n, here it'll be sums of squared divided by degrees of freedom. Again, our degrees of freedom here is n is -1, so n here is 18. So we're going to say, we're going to divide that by, not 18, I apologize, n is 8. We're going to subtract 1 from 8, and we get 7. So 26 divided by 7 is equal to 3.71. And this is our variance for the sample. So again, the only thing that's different between calculating a population versus sample data is what we're dividing that by, whether we're dividing, when we're doing that, divide the sum of squares, here it will be the degrees of freedom versus the number of scores in a sample. Once we get to standard deviation, again, all we're going to do is take the square root of that variance. So we have the variance is equal to 3.71. We'll take the square root of that, and we'll get 1.93. So this ends our quick tutorial on variance and standard deviation for both sample and population data. Thanks so much.